Hi everyone, my name is Muhammad Kaleem, and today we will discuss the first topic of IGSC Cambridge. Okay, let's start. Here is our first topic, that is number and language, in which we have first subtopic is natural number. We are already well known about the natural number, like the numbers that we deal in daily life 0, 1, 2, 3, 4, 5, up to so on. So these numbers are known as a natural number. Only positive numbers here we have in natural number instead of a natural number. And integers, next we have a set of integers in which negative numbers are also included. Here, remember the one thing, we don't have decimal number here. Here we have a whole number, complete number like 1, 2, 3. We don't have 1.5, 2.5 like these numbers. Okay. So natural number, in natural number we have only 0 and positive number. Positive integers, you may say that. And integers, in integers, positive, 0 and negative are also included. So this set of numbers is known as a set of integers. After that, we have a rational number. Here we have a long debate on this one. Rational number, that's very important topic. Here we have a two-way to explain this one. We can understand in two ways. The first one in decimal form. Okay, if we have a number in decimal form, how we can say that this one is a rational number or irrational number? Like in the universe, there have we only deal with three types of number. Like the first type of number is like 6.25, 1000, 500, like these numbers. So these numbers are known as a terminating number. 30. So these type of number are known as a terminating. Terminating means they are finishing after some digits. Terminating. Here we have terminating number. Okay. And the next type of decimal number is non-terminating. Non-terminating and repeating. Again, we have two types in non-terminating and repeating. Like we have a number 1.33333. So these numbers are known as non-terminating because they are never ended. So that's why these are known as non-terminating and repeating. In non-terminating and repeating numbers, one number or a block of a number. Like you may say that 0.125125, a block of a number. Here a block of a number is repeating. 125, 125, 125, 125, like this. So these numbers are known as non-terminating and repeating. Let me write here. Non-terminating and repeating. Okay. And these numbers are also known as a recurring number. Recurring in a single word, recurring number. After that, we have a third type of number that are known as a non-terminating and as well non-repeating. Non-repeating means here we have a number in which digits are not repeated itself in a sequence. Like here you can see a block of a number or a number, single number is repeated itself. So in this type of numbers, we don't have a repetition. Okay. So these numbers in single word are known as a non-recurring. Okay. Like now suppose we have a 5.3498 6 7 8 9 4 5 3 up to so on. So these types of numbers are known as a non-terminating, like 3.14287685 4, like these type of number are known as a non-terminating and non-repeating, or you may say that non-recurring number. Okay. So from these three types of number, we have two types are included in rational number. Rational number, these two types of numbers are known as a rational number. in decimal form. If we have a number, if our answer is in decimal number, and we want to differentiate between rational and irrational, so how we can differentiate? You just have to check, is this a terminating number? If the answer is, if the number is terminating, so you just have to say this one is a rational number. If the number is terminating, then it's rational. And if non-terminating, then you again have to check, is it repeating or non-repeating? If repeating, then rational. If a number with these two properties, non-terminating and non-repeating, that number will be known as a irrational number. Okay, I hope you understand this concept. This one is a very important concept. Okay, after that, we also have another way to understand the rational and irrational number, like the definitions according to our books. Like if a number is written in p by p over q form, if a number can be written in p over q form, and there is a one more condition on this fraction, if a number can be written in fraction and p and q must belong to z. Z means integer. Here p and q must be from integers. If uh, if a number fulfill these two conditions, mean we can write in fraction and both numerator and denominator from integer, so we can say that this number is a rational number. Like if you have a 5, you have a 5, so here this number can easily we can write 5 over 1, because if we don't have any denominator in the number, so we can consider 1. So after that, you just have to this number is in a fraction, it's okay, it's fulfilling the first condition. Now you just have to check the second condition. What's the second condition? Is numerator from z, from integer? Yep. And second integer, second sorry, the denominator is also from the integer. If yes, then it will be a rational number. So 5 is a rational number. Okay. And if a number, suppose you have 3 over 5, this one is already in fraction. You just have to check, are numerator and denominators from the integer or not. If they are from integer, so you just have to say that this one is a rational number. Okay. After that, suppose you have a number like under root 2 over 3. So you have to check, is this number is a rational or irrational? So you have to check, yes, this number is written in fraction form, so it fulfills the first condition, that is the number must be in fraction form. And now we have to check the second condition. What's the second condition? Second condition is that you just have to check the numerator and the denominator are both from the integer. If yes, then it will be rational. But here you can see under root 2 is not from the integer. You can clearly see, firstly we understand the set of integers. In set of integers we have this type of number 0 1 2 3. We don't have a under root 2 in this set. So it means that under root 2 is not from the integer. Okay, 3 is from the integer. But here we have a contradiction in numerator. So this one is not a rational number. This one is a irrational number. Okay, I hope you understand this one. Okay, here we have one more example to discuss here, because this one is also important. Like suppose you have under root 4 over 5. So in the starting, you don't have to make a result, you don't have to give a statement directly. Firstly, you just have to check, is our fraction in simplest form or not? Firstly, if this one is not a simplest form, so you just have to convert into simplest form. Like this question is further solvable, so we have to simplify it further. So it will become 2 over 5. No, you have to check the second condition, that is you just have to check the numerator and the denominator are both from the integer or not. So yes, under numerator, that is 2, is also from the integer, and denominator is also from the integer. So this number become rational. Okay, I hope you understand the rational and irrational. We have two concepts. The first according to decimal, and second one is according to the fraction form. Okay, next we have a definition of real number. In real number, basically, real number is the union of rational and irrational. And rational numbers are represented by Q. Rational numbers are represented by Q. As integers are represented by Z. Natural numbers are represented by N. Okay. So how we can represent irrational number? Irrational numbers are represented by Q prime. Okay. If we take the union of Q and Q prime, so then it will become real number, and real numbers are represented by R. You simply write Q union Q prime. What is a union? Union means the combination of these two. We have to combine rational and irrational, so it will become a real number. The set of real number. Numbers which cannot be expressed as a fraction are not rational number. They are irrational number. Okay. Here they are firstly defining the irrational number. Like which number cannot be rational, that will be irrational. So using the Pythagoras theorem, okay, just leave this one. So you just have to simply remember this definition of real number. The union of rational and irrational number is known as a real number. Okay. So after that, we have a composite number after real number. You may say that real number in this situation, we have a universal set. Okay. After that, we have a set of prime number. What's the prime number? Like, I think I hope you already know about this one because this one is a very basic topic. You may have studied in the previous grade. A prime number is one whose only factors are one and itself. Like a number that has only two factors. Only two factors. What's the meaning of this one? Like if you have a five, here we have only two factors of five, one and itself five. Seven is also have a two factors, one and seven. But if we check nine, there are three factors of nine, one, three, and nine itself. Okay, so the factors are the numbers that divides the given number. Like five is not divisible by any other number, it's divisible only one by one and five. Every number is divisible by one, so one must be the factor of each number. So here we just have only two factors, and seven also have a two factors, and 9 has a three factor, so it will not be a prime number. So these two are prime number, this one is not a prime number. Similarly, you can check 4. In 4 we have again same debate, 1 2 4, and you similarly you can check 8 1 2. 8 has a factor 1 2 4 8, so 8 has a four factors. So the number which has only two factors are known as a prime number. This definition is different from the book, but you can also learn from the book like this one. A prime number is a number whose only factors are one and itself. They are explaining the same thing. Means a number which has only two factors, one and itself. That number will be known as a prime number. And note that one is not a prime number. Why? Because one has only one factor. Okay. We define the definition, we define the prime number, that is a number that has two factors. Okay, so that number is known as a prime number. If you have any question related to this topic, you can comment me. I will answer your question in the comment section. Okay, so next we have exercise 1.1, in which you just have to draw a square box 10 by 10, write the numbers from 1 to 100, and cross out number 1. Okay, like firstly you just have to draw a square shape 10 by 10 table like this one, and then you just basically here they are want to explain the prime number. That's so easy. You just have to write the numbers 1 2 1 2 3 4 up to so on 100. Up to 100 you have to make a table of 100 numbers, and then you have to cross out 1, and then you have to cross out 2. We did this type of work in the previous grade, maybe in grade 4 5. So here basically they are going to find the prime number by using this method. Okay, that's so easy. Firstly, you just have to make a table, and after that, you just have to follow these conditions. Cross out all the even numbers after 2. So even numbers, you just have to cross out 2 and up to so on. Okay. Okay. Cross out every here. We just have to do this one. Okay. Just give me a minute. Let me paste a column table here. So then I will explain this exercise. This exercise hold only one question, so we have to complete it. Just give me a second. Okay, here we have a table from 1 to 100. Now, what we have to do, firstly, you just have to cross out the first condition. You have to follow first condition in which we have to cross out the number 1. So we have to cross out number 1. After that, cross out all the even numbers after 2. So you have to cross all these even numbers 2, 4, sorry, you don't have to cross the 2. After 2 you have to cross all the even numbers: 4, 6, 8, 10, like all these numbers: 12, 14, 16, 18, 20, 22. So all these number you have to cross out. Let me cross this one quickly. If you have any question related to this topic or any other topic, you can ask in the comment section. I will answer them. So basically, these numbers are not included in prime numbers. Okay. After that, you have to follow the third condition, in which we just have to cross out every third numbers after 3. Every third number after 3. So 1, 2, 3. This one is already cross out. So it means that here we have to cross out the multiple of 3. After this one, 1, 2, 3. 1, 2, 3. Already cross out. This one, you have to cross out this one. And this one is already cross out. So after that, this one, 21, 24 is already cross out, 27, and then 33, 39. And similarly, you have to move forward. You have to just cross out the multiples of 3. Okay. So here, 51, this number will also be included. And 51, after 51, 54, 54, after 54, 57, after 57, 60, then 63, then 66, and then 69. After that, 16, 72, 75, 78. After 78, we have to cross out 81, 84, 80, 87, 87, and after 87, you have to cross out 90, 93, 96, 99. Okay, we just complete the third condition. Now you just have to follow the fourth condition, in which we just have to continue with 5, 7, 11, and 13. Then list all the prime number. You have to follow this step. Like if we have a, we have to cancel out the multiple of 5. Or you may say that every fifth number after 5. You don't have to cross out 5, 10, and then 1, 2, 3, 4, 5, 15, 1, 2, 3, 4, 5, 20, like this. Okay, these rows are already cancelled out, like 20, 30, 40, 50, 60, and I think no, here we also have to cancel out 25, 35, 55, 65, 85, and 95. Okay, next you have to continue for 7. It means that no, we have to cancel out the multiples of 7, except 7. So just leave 7, and then 14 is already cancelled out, 21, 28. After 28, we have a 35. 35 is already cancelled out. So you just have to continue like this. Okay, and the remaining number will be prime number. Okay, I hope you understand this one. Okay, next we have a square number, or we can find the square of a number. Like you just simply you just have to multiply number with itself. Like if you want to find the square of 3, you just have to multiply 3 with 3. Okay, like if you want to find the square of 15, so you just have to multiply with itself. You have to find the square of 15, so it means that you just have to multiply 15 with 15. That will be equal to 225. Similarly, you can easily find the square of any number. The simple words, what you have to do, you just have to multiply it with itself. Okay, like if you want to calculate the square of 7, so what we have to do, you just have to multiply with 7, 7 itself with 7, find the times between them, and then it will be equal to 49. Okay, that's it. This one is the concept of square number. Next we have a cube of a number, or we can calculate cube of a number. Okay, like if you want to calculate the cube of any number, like 4 cube, so how we can calculate? You just have to multiply 3 times, like 4 times 4 times 4. I hope maybe you heard about the index laws. Here we have following the same thing, scientific notation. 4 raised power 3 means you just have to multiply 4 3 times. Let me explain the index law also here. Suppose if you have a 5, 2 raised power 5, so it means that you just have to multiply 2 5 times. 2 times 2 times 2 times 2 times 2. Okay, so here if you want to find the cube of any number, so you just have to multiply 3 times. Like if you want to find the cube of 4, so it means that you have to multiply 4 times 4 times 4, that will be 64. Same debate on 3. Okay. Okay, that's the concept of cube of a number. After that, we have a factors of a number that I think I already explained here in the prime number. What are the factors? Factors are the number that divides the number. Like if you want to calculate the factors of 12, so you just have to check uh, which number divide the 12. So that are 1, 2, 3, 4. 5 is not divide the 12. 5 didn't divide the 12. So you don't have to write 5 in the factor of 12. 6, 7, also not the factor of 12. 8 is also not the factor of 12. And then 9, 8, sorry, 8, 9, 10, 11, 12. 12 divide itself. So these are the factors of the 12. There is a simplest way to check out all the numbers. Like if we have a bigger number, like if you want to calculate the factors of 49. So we don't have to check all these numbers like 1, 2, 3, 4, 5. There is a trick to find out the factors. Look, you just have to start from 1. Which number we have to multiply with 1 to get the to get 49. So it means that I have to multiply 49, right? So it means that 1 times 49 become 49. Similarly, you have to move for 2. Is there any number with which we have to multiply with 2 to get 49? No, there is not a single number that multiply with 2 to get will be equal to 49. 49 is not derived from 2, so we have to skip 2. Similarly, you have to check for 3. For 3, is there any number? No, not for 3, not for 4, not for 5, 6, 7. Yep, here we have a number 7 times 7. So here you can see the number is repeating itself. Okay, you just have to stop at the point when the number is repeating. So after that, you just have to write the factors. 1, 7, and 49 will be the factors of 49. You just have to stop here and just write all the numbers that we have here. Okay, let me explain another example, then you will understand better. Like if you have want to calculate the factors of 36, how we can calculate? Like firstly, you just have to check 1 times 36. This one will be the pair included in each number's factor. So 1 times 36. And after that, you just have to check for 2. So 2 times 18 become 36. And after that, 3 is 3 divides the 36. Yep, we will get 12, right? And then for 4, yep, we have a number 9. After 4, which number we will get? Like 6. 5 is not 5 not divide the 36. 36 is not visible by 5, so we will skip 5. After that, you just have to check 6. Now here you can see 6 is repeating, so we have to stop here. Now you just have to easily you can easily write the factor of 36, that are 1, 2, 3, 4, 6. You don't have to repeat 6, 9, 12, 18, and 36. So these are all the factors of 36. Okay. Okay, let me explain one more example. Like if you have 40, 42, suppose 42, you have to check the factors of 42. So what we have to do, you just have to firstly check for 1 times 42. After that for 2, 2 times 21. When we divide 42 with 2, it will be equal to 21. Yes. So after that 42, you have to divide it with 3. What will be its answer? Its answer will be 14. Okay. And for 4, 42 is not visible by 4, so we have to skip 4. For 5, no. For 6, yep. For 6, we have a 7. 6 times 7 become 42. So after that, uh, for 7, 7 times 6. But here you can see, again, the numbers are repeating itself. So it means that we have to stop here. In the previous examples, the number is repeating itself in the same pair. Here we have 6 is repeating, 7 is repeating. So it means that you have to stop here. Now you just have to write the factors of 42. There will be 1, 2, 3, 6, 7, 14, 21, 42. This one is a trick to find the all the factors of any number instead of checking all the numbers. Like if you want to find the factors of 42, you don't need to check the all the numbers after 6, 7, 8, 9. You don't have to check 11, 12, 13, 14 is already in the factors. So you don't have to check all these numbers. So this trick save our time. We also have to save our time in exam, so that's why you have to use the tricks. If you still have any confusion, you can ask in the comment section. Okay, next we have 1.2 exercise in which we just have to write the factors. Like you have to write the factors of 42, 25, 35. I hope you understand how we can find the factors. So if you have any confusion, you can ask. Next we have a prime factors. How we can find prime factors? Like now we already know that how we can find the factors. Firstly, you just have to find the factors. Then you just have to pick the numbers from the factors that are prime. Like in the same example here, let me uh, make a copy of this example, then I will explain. Just give me a second. Mm. Okay, here we have example. I just wrote all the factors of 42, but no, we have to pick only prime factors. You just have to write only prime factors of 42. Suppose here we have a question 42 in which we just have to write the prime factors of 42. Here these are all the factors of 42, but in this question we just have to write only prime factors. So in prime factors of 42 we will write only 1 is not a prime number, 2 is a prime number, 3 is a prime number. We will not write 6. Why? 6 is a factor of 42, but it's not prime. So you just have to pick prime and factor. So 7, and after that 14 is not a prime number, 21 is not a prime number, 42 is not a prime number. So prime factors of 42 are only these 2, 3 and 7. I hope you understand this one. Similarly, in all these questions you just have to find the factors and then you just have to pick only prime factors. Okay, so after that here we have example. Find the prime factor of 18. We did 1.2 and 1.3. In next class, we will do 1.4. I think that's enough for today. Let's revise what we did in this class. Firstly, we understand what's the set of a natural number, integer. In natural number, we have only positive and zero numbers. 0, 1, 2, 3. In integers, we have a negative and positive and zero. Okay, in rational number, we understand the concept of rational number by using the decimal number and the fractional form. After that, we understand what is the definition of prime number and how we can um, calculate the prime numbers up to 100 by using this table. Okay, after that, we also understand how we can find the square, cube, factor, and after at the end at the last of this class at the end of this class we just understand how we can find the prime factors. I think that's enough. If you have any question you can ask in the comments. Take care. Goodbye. If you like this video, you have to subscribe my channel.